Okay, welcome all of you. This lab is going to be a little different from just writing Python. It's going to be a multi-threaded application, not a very big application, a small one. Okay, so let me um, tell you what I plan to do today. We cannot write any decent application without knowing about at least one mechanism for protecting the data and then one mechanism of inter-process communication. Okay. So we cannot write a multi-threaded application without these two, at least one of the features supported by Python. So what I thought, I will teach you only two. If you are then once you are aware and you understand how to use it in a real multi-threaded application, other features that are supported by Python can be learned on your own and you can adapt it to your application based on the need. Okay. Now let me tell you why I need this logs and message queues before even we go into the details. As I told you, the multiple threads T1, let me call it as T1, T2, T3, they all operate within a process. I'm sorry, this is not good. So let me draw something little decent enough. Looks like a circle. Multiple T3, T1, T2. Okay, now this is some data. Okay. Now, if these threads need to run in the context of a process, they need to operate on some data which is shared between the threads. Now there are two things. If first of all, the thing is the threads are there within the process because they are doing something which are related to each other. They are cooperating task. They do something where one output is required for the other task, something like that. Okay, they are operating on a shared data, means they are doing a common job. Maybe they will be doing different part of the job, but they are all for a common application. That means the threads which are running in parallel, they need to be able to access the data in without causing any issue. That means if they are reading something from the common database and the same thing is getting written into by some other thread, both of them are running in parallel and there is a possibility of a race condition. I'll tell you what is race condition. But when a bet data is getting written into by T3, it should be completely written. That means it's not in the halfway through that this guy reads it. Okay. So there should be some mechanism which is a lock, okay, which should be used to protect the data that we are using. That's one thing. And then we should be in a position to exchange some information with another thread if they are all working on some common thing. Suppose if it finishes something, instead of putting it in some shared database, they can communicate it using a IPC mechanism, inter-process communication mechanism. What we are going to use is a message queue, which you might have already studied in your OS course. So now message queue is easy to understand more, and what is difficult or not understood well by people are about the lock. What is the need for a lock? How does the lock work? And then how is it protecting that two different threads accessing a common database? Common data. When I say common database, it can be just one integer. Okay, C. Okay, I'm writing in C. One integer variable also a common data. Now, let me explain why we need to have a lock if a count variable is just an integer variable. Maybe I will assume it as a 32-bit value, is accessed by two threads, maybe T1 and T2. One may be writing into it and other may be reading from it. Now, what is the issue here? The issue here is when you are updating the value or incrementing, suppose it may be reading and writing. Okay, it reads the value and writes into it, suppose. it does maybe count plus plus, count plus plus, and this guy is just reading it, and then it is reading that value from the global to some local variable. Now, when a variable is getting incremented, it is finally getting converted into a CPU assembly program, which will be like, assuming that we have the register R1 has the address of count variable, and then we want to read from the memory. So LDR, which is a load register R0, R1. Now I am showing some ARM instruction where R1 is the register which is having the address of count, and in that address whatever is the content is written into R0. Now the value of count is taken from the memory. Okay, please remember this is in memory, maybe in the cache or in the main memory, what doesn't matter, but it is memory read. This is a load instruction, is a memory read. It reads into R0, then it will perform addition of 1, R0, R0, immediate value 1. That means you are incrementing the value by 1. Now this value has to be written back to the memory, which is str store R0, R1. Now it goes like this. So these are the pre-assembly instructions which perform the job of count plus plus. Now what is the issue? That why do we need a lock? Okay, why do we need a lock to make sure that this value is, you don't get the intermediate value? The reason is the processor which is executing these instructions, they execute one instruction at a time, and mostly the LDR and HDR may take 2 cycles or more, but this may take 1 cycle. Assuming that even if it is all 1 cycle instruction, that means ARM processor is running at some maybe 100 megahertz. I'm just telling you a embedded processor. Then in that clock rate, it is going to read the execute this instruction every clock cycle, but it can recognize interrupt at every, after completing one instruction it can be interrupted and the processor can go off to service an ISR. Now imagine a situation where this ARM is running a OS and one of the threads T1 is doing this count plus plus like what I showed you. Then the interrupt what you are getting is a timer interrupt. And imagine this is the interrupt which is a timer interrupt ISR, and then based on the timer, maybe this task completion has happened, the time slice is over and scheduler is called. Now T2 is scheduled. By the time this instruction, after this instruction is executed, it is not coming back to this. Now T2 is scheduled. Okay, that's possibility is there. Now when T2 is scheduled, that is going to execute again, maybe only store, maybe it was reading it, so it will be executing a store instruction. Then it will read a value which is a stale value, or which is in between this addition. It will read the value which is there in the memory at this point. But when the scheduling comes back and T1 is scheduled, then the rest of the instructions are activated and it will write into it. Now problem will be worse when 2 tasks are trying to write into the variable, or 2 things are incrementing it in parallel. Then what will happen is, if an interrupt happens here, you are disturbing the flow of these instructions completed, because this whole thing needs to be done in one single flow without any interruption in between. Then only you can have a right value of R0 which is incremented properly. Otherwise you will have a race condition here that the count may not be incremented. If 2 tasks are trying to increment it, all these problems will happen. So to protect it, what we do is, in the OS we say that any task which is trying to access this count should acquire a lock. Now what is lock? Lock is provided by the OS. Then lock is also implemented in software. It is also a OS data structure, a semaphore, which is a bit, maybe 1 bit or 1 flag, which is, if it is set to 1, lock is available. If it is set to 0, it is not available. Now this lock itself should be implemented in such a way that no interrupt is happening when the OS is trying to read the lock value, and then if it is set, it should set. No, if it is already set, it is free. One means free. Then one task is asking for a lock, then it will see that it is 1, then it will make it 0 and give the lock to the thread. Now reading this value 1 and writing the 0 should be done atomicity. Okay, this is called atomicity or atomic operation, without any interrupt coming in between. So this kind of multiple instructions may lead to problems. So what happens is test and set instruction. There are some processors do this. So you test the semaphore lock. If it is 1, you set it to 0, okay, or something like that, okay. Normally this will be done, and then when you are releasing it, you make it 1. So once this variable is atomically modified, then this can be used as a semaphore for any other task to before accessing any shared variable, it should access the lock first. So suppose if count has to be there, count has to be accessed, you need to say that I will have a lock which is called maybe count lock, which I am going to use it, which is a lock provided by the Python now, which is actually Python is not providing, it is taking it from the OS most probably and giving you a lock. Now what happens is when any thread comes and asks for the lock, it will be blocked if it is not available. That means if its value is equal to 0, it is not available, it will be blocked. That means what? If it is blocked, someone else is owning the lock. Okay, some other thread has already acquired the lock and it has made it to 0 and it is owning it. So that means it should release it. So the task which is owning it, suppose TX is owning it, TY wants to get the lock, it is not going to get, it is going to be blocked. Now TX acquired it first and then it has made it to 0. And then it uses the count, it accesses the count and does something, and then it says I want to release the lock. So make sure that whenever you acquire the lock, you have to release the lock. It's the same lock, okay. I am saying count lock, you are releasing it. Then once you release it, it becomes 1, then the block task will be woken up and it will be given the lock. Again the count will become 0 and this new TY task thread Y is now in the critical section. That means it is now free to access the count and modify it, because what we are trying to do is using the count, we make sure that only one thread is modifying the value and no other thread is allowed to enter it. Now, how do you make sure it is not actually multiple threads are not using the count? That is the discipline that all the threads using the count should follow. It's not that OS is going to police you saying that, oh, you are accessing count, you are supposed to acquire the count lock, why are you not doing? It doesn't even know, OS doesn't even know that this lock is actually protecting a data which is count variable. It doesn't know. We as an application developer associate a lock with some associated variable or a job or a database. So when a particular task wants to use the count, they should have a discipline to say, I want to acquire the lock. That's a system designer decides that, okay, if any threads wants to use a shared variable, they should acquire the lock. Which lock? They will decide, okay, count lock is the lock which is going to be protecting this variable. That is an understanding between all the threads. So everybody will say acquire. One of them will succeed, and then whoever gets the lock, they will finish the work. And normally this is called critical section, and it is supposed to be that the critical section should be done in a short duration, because you are making other threads wait while you are doing it. It's like when you are going to a bank and you are accessing your locker. The locker is common for all the customers of the bank. You cannot go into the locker room and sit there for a day doing something. Okay, it's not allowed, because the locker is common for multiple customers. They will also be willing to come to access it. So but only one person will be allowed inside the locker room. So you have to finish your job and come out, and then the customer, the bank employee, make sure that you are out and then another person enters the locker. So similar way, when you are operating on this data which is being protected by a common lock, you acquire it, use it, and then make sure that you release it. Okay, immediately after the acquiring, and once your job is done, release it. But once you release it, don't try to change the count value, which is illegal. Okay, always you should have the discipline to acquire the lock before you modify it. So similarly, all other tasks also would do it. Okay, now who will get the lock is decided based on the implementation, whether it's FIFO based or round robin based or a priority of the task based. There are all different mechanism used by the OS, and in Python we are not bothered about that. So we just acquire the lock, use it, and release the lock. So this is the principle of lock. Okay, this is how it is implemented in the operating system also. I thought not only you learn semaphore, but you also learn about how it is implemented inside, and the processor CPU supports and provides some instruction so that it is the instruction what you have is not interrupted in between, and it can do the job. Test and set is one sample example. Okay, so this is all what I want to talk about lock. In case if you have any questions, please ask me now. Otherwise, we'll go ahead with the further discussion. Okay, so all of you are aware of it, I presume, and let me start off what I want to do in this lab. A race condition, which I mentioned, is a significant problem in concurrent programming or multi-threaded or multiprocessing environment. The condition occurs when one thread tries to modify a shared resource. When I say shared resource, it could be a database or a variable, a simple variable, or it could be a file, whatever it may be. At the same time that another thread is modifying that source. So you allow two people to modify it, a common source, then you are going to have a confusion. This leads to garbled output, which is why threads need to be synchronized. Okay, they need to be synchronized in the sense you allow only one thread to use the data, okay, the common data, which is being shared by multiple threads. Threading module of Python includes locks for synchronization tool. As a synchronization tool, there are two states, either locked or unlocked. Locked means it's not free, unlocked means free. So there are only two states for the lock. It's a binary semaphore. There are counting semaphores also there, where n number of states may be there, but we are only interested in protecting a critical section or a database. So we actually, what is critical section is, critical section is a piece of code which is operating on a common data. Okay, that is called the critical section. And critical section actually refers to the code which modifies the data, and the resource what we say is the data. This is called resource, and what is protecting is the semaphore or mutex. Okay, I'm not going to details of semaphore or mutex here. We are calling it as a lock. It's a binary lock. That means it will have only two states, either free or not free, or locked or unlocked. Now a lock can be locked using acquire method. You need to acquire it, and then once a thread has acquired the lock, all subsequent attempts to acquire the lock are blocked. So when particular thread has acquired the lock, okay, T1, T2, T3, if they try to acquire, they will be blocked. So that means they will not go further. They will be woken up only if the lock is available. Till then they will be blocked. Okay, remember that they won't be able to come further. That means you can write a code, acquire lock, okay, then modify count, then release lock. So you will be doing it assuming that when it comes down, it has already got the lock. If it has not got the lock, it will be blocked here. Okay, so that you can assume. Okay, who is doing it? That is the implementation of the locks module, which takes the help from OS and make sure that thread is not going further until the lock is free. So that is what is expressed in this line. The lock can be released using the release method. Then what happens is, when a thread which is owning it, T1 is owning it, when it says release, now what happens, T2, T3, both of them are locked and blocked here. They are looking for the lock and they are blocked. Now OS or the library decides to free one of them, allocates the lock to them, and then maybe T2 will come down or T3 will come down and execute the code that you have written next. And then it will say release. then the other guy will come down and finish it, and they also say release. So in a normal condition, the lock will be free and it is ready for anybody to acquire. But once one person acquires or one thread acquires it, then it will be owning it, and that thread needs to make sure that it releases also without forgetting it. Okay, that is always a problem, that if you don't write the code properly, if you acquire it and don't release it, then there will be a deadlock. No other thread is going to get the lock, and it will be a deadlock. So small mistake, if you don't have a matching acquire and matching release, suppose your function acquires the lock, but without releasing it, it returns, then you are in trouble. Okay, that you should take care that even if you have a multiple control flow, it releases it. Similarly, you should not release the lock which you are not owning it. You cannot just say I want to release it. You should own it first. You should have acquired it first before releasing it. These are all some conditions you need to take care when you are writing the code. But whatever I am asking you to write is a very simple code where you will not make a mistake. But if you are really writing a bigger application, you need to be careful about it. So calling the release method on a lock in an unlocked state results in an error. It's already, if it is unlocked, you are trying to release it, you cannot do that. Okay, so you should have acquired it first. Similarly, somebody would have acquired it, and if you are releasing it by mistake, it might allow you to release it, but some other thread is going to have a problem. So never make a mistake of using the acquire and release in a random sequence. You should always acquire first and make sure that you remember to release next. Okay, and use now, as I told you, the lock is used for a purpose. So you can have a, I will tell you where I am asking you to write a application where you will use two locks, and then you will be writing the application. Okay, that is about the lock. Any questions on the locks from anyone before I jump to message queue? Okay, now message queue. Very simple comparatively. No, locks, it is simple. This is a common resource queue, T1, T2. If they have the handle of the queue, they will be able to put a message, and then somebody can be able to get the message from the queue. Now putting means it is in the FIFO order, so it puts the message, and then the same order, if some other thread is really executing the get, it will get the message. So very easy to understand it. Now what if there are two conditions where when you try to put it, the message queue is full, then this task will be blocked, the producer will be blocked. Now what if you are trying to read from the queue and the queue is empty, no data, then also this will be blocked. So these are the two conditions, blocked, and other cases it will be successful, that you are able to put the data. As long as the queue is having sufficient space, you can be able to put the message 1, 2, 3, and it will be read in the same order. Okay, so normally the message queues are implemented such a way that they don't overwrite any message. If it is full, it will be the producer will be made to wait until somebody consumes it and there is a space created in the message queue. Okay, so that's how it is implemented. Now we have queues can be used for multi-process, multi-threading programs where you want to exchange some information between two threads, not through memory, but you are passing it through a message queue. Actual data is getting passed. Queue provides us a thread safe FIFO. Okay, so the message queue operation is thread safe. When I say thread safe, you don't need to acquire a lock before using it. Okay, you don't need to acquire a lock or release a lock before using the queue. It is because you know that queue is also a common data structure, common data which is being accessed by two different threads. The implementation below takes care of protecting it. Okay, so you don't need to worry about it. That's what I'm saying. Okay, you don't need to have a lock to before accessing the message queue. Like a stack, queue is a linear data structure that stores items in first out manner. With a queue, the least recently added item is removed. That means the oldest data is removed. Queue puts an item into the queue, and queue get. This is the Python methods to get an item and put an item into the queue, and it gets an item from the queue if there is one. Otherwise, the thread is blocked until an item is available in the queue. Okay, So you don't need to worry what happens if the queue is empty, should I check it or not? No, it will come out from the queue only if there is a valid data in it. Okay, so queue is implemented thread safe, so there is no need to have a lock while acquiring the queue or operated on by multiple processes or threads. I am saying the same thing here, and you don't need to worry about that. Okay, that's all about message queue. Any questions on message queue from anyone? Okay, now let us look at the problem. I want to use one lock, count lock, to protect the variable count. There are increment thread, prime thread, divisible by 10 thread, divisible by 25 thread, and a dummy thread. Now what they do? Before that, there is a print. See, yesterday we saw that the print messages were garbled and one after the other they were coming. So I want to just make sure that you print it using the lock. Whenever any thread is printing, it's going to acquire this lock and print the message. That means you see one print coming from one thread, another thread on a next line. It will not be garbled here like this. Okay, what you saw earlier. So there are two locks for different purposes. So this is only understanding of our application. When we are writing application, we are associating that this lock will be used for accessing the count variable, and this lock will be used for printing any messages by any of this thread. Okay, that's the understanding, first understanding. Now what is they doing? The increment thread job is to just increment it every 1 second. Okay, every 1 second this guy will come up and increment it by 1. That's all. Okay, now what is the prime thread? Prime thread is going to use one library function. Okay, I forget the implementation. Okay, is prime, oh sorry, sympy, I think, yeah, sympy library. Okay, and it has is prime function. Okay, so you have to import sympy and then sympy dot is prime. Okay, you can also find out yourself how do you find a prime number, whether a given number is prime or not. I don't want you to write the code for it. You can get the library function. I use the sympy library, and which has got a is prime method, I think. Okay, so what is it doing? This thread is going to read the count. Okay, I'm just showing like this, but it is reading it, it's not writing it. Okay, maybe I should have put it like this, but I'm just showing that they are accessing the account. Okay, accessing it. Okay, no, don't think that it is writing or something. Okay, so it reads the count and then checks whether it is a prime number. So imagine count is started with 0, 1, after 1 second 2, 3, 4, 5, 6, 7, it goes on. This thread job is to just keep incrementing the count. That's all, it doesn't bother anything. Now each of these threads are going to sleep for 0.5 second. Actually, I made it intentionally so that they check the count more often than the increment thread is incrementing it, so that they don't miss out on any intermediate numbers. And then whenever they check it, they check the prime number, checks for these numbers. Okay, like this. So, and then if it finds that it's a prime number, that library will return true. Then it is going to acquire the print lock and then print the message saying that, oh, I found that prime number, count is this, so and so, the value is 2. I'll show you the output, and then it will go to sleep. This guy will wake up and then check whether the count value currently is divisible by 10 or not. So until value becomes 10, this guy will come and check and then goes out. It is periodically checking it. Whenever it finds that it is divisible by 10, it will print it. While again printing it, it will acquire the lock and print it. This guy will check for 25, divisible by 25. Now, all these threads are having some name, and then when I'm creating the thread using the run method, they will be called a different method, which is running forever. Okay, they run forever, and they wake up every 0.5 second and does this job of checking the count. But remember, before accessing the count, it should acquire the lock and then check the count. Maybe it can copy into a local variable. Okay, Don't do any other checking and all that. Just don't call the library function within the critical section. Copy the value into one variable, local variable. Okay, you are taking a sample of it, not in the middle of changing, but you are taking a sample which is stable enough. You take the sample, write it to the count variable inside a local variable, and then you check whether it is a prime number or not. If it is so, then acquire this. Don't acquire this lock and this lock together. Okay, it will be a deadlock. Acquire this lock, copy the value, release it. Your job is done. Similar, then check it. Any of the check you do, then acquire the lock, print it, then release it. So please don't do acquiring this, releasing together, or don't keep the lock and then try to acquire this lock. You are getting into a deadlock. Do not do that in any of the piece of the code. In mostly, even in your day-to-day application development, you should avoid no, unless it is very application specific and you want to acquire multiple lock. You should never acquire multiple locks, and there is a likelihood of deadlock if you do that. So when you do this, then what happens finally is this will keep on incrementing the value. It goes forever and all of them are running forever. So you get the output continuously. Whenever prime number is found, this guy will print. Whenever divisible by 10 comes, it will print. This will print whenever 25 comes. This guy is a dummy thread which says I am a dummy thread, I am a dummy thread. Every 10 seconds it just prints it and goes to sleep. It doesn't even access the count. Actually, I should not, one second. It is not accessing the count at all. Okay, it doesn't have to access. So maybe, okay. Is that problem clear? Anybody wants to ask any doubts? Okay, now let me tell you some more intricate things. All tasks need to acquire print lock before they print the count value which found to be satisfying the condition. Okay, do not print everything out. Okay, then there will be a clutter of messages. Only when you find a prime number, you print it. Only when you find a divisible by 10, you print it. Okay, only then you print it. So that is one thing. Now one more condition I want you to take care of, which I found out when I run it. No task should print the same value twice. Okay, you may wonder how is it possible. I will tell you. This is running every 0.5 second. Everybody is running every 0.5 second. This is incrementing it once in 1 second. So there is a possibility that this thread samples the same value twice. Okay, suppose if it is at 7, it reads it, it finds 7 in that time, and then it prints the value 7. Then again 0.5 second is over, it accesses the count and finds it 7, it will print 7 again. I don't want to see 7 coming out. Okay, so you need to handle it internally. I will not tell you how to handle it. You guys are software guys, you should know how will I handle this, that I am not printing the number which I have seen earlier. Okay, so it's very simple, very logical. So try to do that. Okay, I don't want to say the output which is coming out. Please, one more thing, please do not copy code. When I look at all your assignments, if I see that the copying is all around, then I need to give 0 to everyone. That's what I did for other students. I hope that you are not going to do that and you are not doing it. Please try to do it yourself, and which will help you in the exam also. And I request you not to be honest when you are submitting the assignments. Okay, so okay, I'm sure you are, but just want to be, just want to make sure that you are all on the same page. We are all on the same page. Okay, this is what I want you to do that twice. Then verify that no valid value is missed out. Okay, that's also one important thing. Suppose 2, 3, 5, 7, they're all prime numbers. I don't want to see that 3 is missed out. That is not possible here because you are sampling it more frequently than the incrementing happening. This is 1 second. That's the reason I changed it. I could have told you to manage the thing on your own, but I told you I don't want to do that. So I told you that I'm telling you that you make them all 0.5 seconds so that they sample more often than this, so that all of them get a chance to sample. That means all the values are not no value is missed out. So 10, 20, 30 should come out, 25, 50, 75 should come out. Nothing should be missed out in your output. Okay, so this is the condition. This is the first problem. Now some inputs, define my thread and use the run method, which create multiple threads based on the name of the thread. Okay, you can call different functions for that. Write individual functions which is called by each of the threads inside the run, and each of these functions never return. Okay, you make sure that they are inside a while true. They now none of them return. They are going to run forever. Write your code within an infinite loop. Create a count as an initial value with the initial value 0 as a class attribute within my thread. So let it be a count is a normal count which is within the my thread. Okay, it's not specific great thing. Okay, just because you are protecting it with a log, you don't need to worry about count. It's a normal variable count. Create a count log and a print log within the my thread class. I will tell you what is the code to use it. This is the one. Threading.log is a log creation, and you are creating a count log and print log. So you keep it inside the my thread only, so that it is common across all the threads. They are going to use the same log, so they need to have the object log object accessible to them. I'm keeping it inside the class itself so that it is within the thread class. Make sure that count log is acquired before reading or writing the count variable, and also the same log is released after the value is read and written into. Make sure that you are immediately releasing it. Okay. Similarly, acquire and release print log before printing any message. Any of the threads are printing it. Increment log will not print anything. It will quietly print, increment and go off. Whereas other tasks are printing it, and they are all print only when they have a valid value. If it's a prime number only, that the task will print. Only if it is divisible by 10, it will print. Not all the values it reads, it is going to print. Okay, so print only valid values, but acquire the log before printing, and release the log, of course, after the print. So all the threads will be running forever, printing the values as shown in the output given in the next slide. So I will show you the output, input and output. This is the input. Okay, you are naming the thread as increment thread. You are creating an increment thread, prime thread, div by 10 thread, div by 20 thread, and dummy thread. And then you start all the threads. Okay, all of them you start one by one. Please see that I am starting this first, and then the prime thread and other thread, and I'm starting all of them. Once you start all of them, they all run forever. And what will happen is the output, whatever I am printing, will happen, and it will go on. Okay. Now, before that sample code, how do you want to create, acquire, and release? You know that count log is within the mythread class. So mythread dot count log acquire. Okay, that is what you need to use. Okay, just you write this. Okay, it will come down if the log is acquired. Okay, so you don't need to worry. This is the code. That's all. And then you read the count. Okay, I told you that in the critical section you should not do too many things. So just read it into a local variable. Okay, as I told, count is a class attribute. So mythread.count, and then release it immediately. That's all. So you should spend as much as minimum time within this critical section. Okay, and this is just acquire is enough. You don't have to check if it is true or nothing. Okay, it will be blocked. If this thread control will be blocked if it is not acquired. And when you come down, you are assured that you have the lock with you. So you release it, you do whatever you want, you read it, and then release it. That's all. Okay, that's what you need to do, acquiring and releasing. And what is the print? Whenever you are printing, what you do? A similar thing, print log, you use it to acquire it. Then do a print message, whatever you want to do. You see, I am printing the name of the thread so that you know which thread is actually printing this message. And then the count value. I am maintaining some local value, okay, which I read it, okay, from the count. Don't try to use the count here, okay. Don't use this variable here. And then do not, okay, I am using this variable, so I will acquire the log. So do not put the log again, my thread dot count log acquire. Don't do that, because if you try to acquire two logs in a different sequence, deadlock is going to happen, okay, which you should have studied in your OS course. So it is okay, whatever value you have taken, and this value you are checking it whether it's a prime number or not, and then you are printing it. That's all. Okay, it doesn't have to be accessed from here. Okay, it will be different from what you have checked actually. When you print it, it may be different from what you have checked. So do not try to print something else. Okay, what you're checking, that value should be printed, and do not acquire the lock for it because it's your own copy. Okay, so I hope you understand what I'm trying to tell you, or what I'm trying to ask you to implement. So let me show you the output. Okay, I will explain everything and then I will give a time for you to stop and ask me. Okay, now see, this is the output. It says that main thread, it starts all threads. Then inside the init or run method, I think inside a run method or somewhere I have printed this starting. I am starting all these things. Then see here, 2 3 2 3 5 7, they're all printed by the prime thread. Okay, that's percentage s name, and the count value is 2. What it has tested was count. Okay, and then dummy thread, already 10 minutes 10 seconds have elapsed, and this guy says my dummy thread does nothing. Then 10 seconds elapsed now. Okay, then it is printing 10 because this thread would have found out that value is 10, whereas prime thread is not going to do it. Prime thread is printing 11, 13, 17, 19, and then 20 is again divisible by 10 is printing it. Okay, so it will go on. Okay, this is what is the output that you see, and prime thread is printing, and then this guy is printed by 25 div by 25, and then it goes on. Okay, and 30 is printed by 10, like this it goes. Okay, now you see 50 is printed by both the guys because it is divisible by 10 as well as divisible by 25. So they are all independent. Okay, they are all running independently and looking the value at count, and all of them are sampling the count more often than the incrementing speed. So they are likely to get all the values, intermediate values. Remember that they are all sampling it much more than they output. They output only when they find that the value is meeting the requirement. Okay, so this is the first problem. Okay, any questions before I explain about the second problem? Okay, okay, let me take a poll now because you guys are not responding. Then how do I know whether I am talking to myself or not? Please raise your hand if you have understood problem 1. Okay, not many. Okay, all of them. Okay, thank you. Okay, I'm not asking you, forcing you, but if you don't understand it, please tell me. I am willing to explain. And if you are not around, then okay, what did I do? I have to say, how do I start the presentation? Okay, I forgot. Okay. Okay, hope you all understood problem 1. I will run it and show you. That is not a big thing, but before that I will show you the problem 2 explanation. What you need to do is take the same implementation, copy to problem 2, and then what I want you to do is individually, instead of these threads printing it, I want each of the thread to pass the number it finds which meets the requirement. That means 2 5, okay, sorry, 2 3 5 7, it will send it into the message queue. This guy will send 10 20, this guy will send 25 50. Okay, this actually this doesn't send anything. Okay, this guy is just running, doesn't read the count or doesn't send anything to it. Okay, so now why did I put it? Actually, suppose you are calling the thread which some name which is not meeting these any of these names, then there should be some default case. So I am any dummy thing or any variable I want you to print, I want you to create a thread which runs with the name. That's all. Okay. So that's the reason I put it, because always you should think about someone calling it with the name which is not defined in your code. Okay. So now what happens is the same code is running now. Once you are successful with problem one, implement the problem two using the queue now. Take out the prints that it was there inside this methods. You can remove those prints because they were printing it directly. Now they are going to um, use the queue, numq, which is called numq. It is going to send us numbers by put. They are going to put it, and then display thread, you have to create one more new thread which was not there earlier, which is its job is continuously wait for something to come on the queue. If it gets something, then it will read it, it will blindly print it. It doesn't have to do anything. It doesn't have to check whether it is a 10 or a 25 or something. It just prints it, and then it goes again, waits for the queue, wait for the data on the queue. That's all. Okay. Of course, you may wonder, why do I need a print lock when only this thread is accessing the print? It's a valid question, but because we have created it, I don't want to lose it. So let us use it. Even this guy, let it acquire the lock, print it, and release it. Okay, that's what I want you to do. Now explanation. How do you create the queue? Again, the queue is also part of the thread. From queue, small queue, import queue, then create a queue object numq. Okay, that's all. Okay, that's very simple, and you don't need to install anything. It is built in. This library is there. You don't need to worry about it. Okay, it will just work. Take the implementation of problem one and extend it by adding numq. The code is given. Create a new display thread which you are aware, which is only job is to print it. Let all the threads send the number they find satisfying its condition to numq. Okay, that's what I said. You should send only 2, 3, 5, 7, not any other intermediate numbers. Okay. Display thread waits on the numq forever. Whenever it receives any number, then it prints the number by acquiring the print lock, and after printing it, releases the lock, and then again waits on the queue. Okay. The code and the output means calling it, not actual implementation. I'm not going to show you the implementation, and I'm going to show you the output. Now, what you do, display thread you create, because I want a display thread to be created first, because that guy is going to wait on the queue. Before that, I don't want this thread to push data into the queue and then overflows. So that's the reason consumer should know, when you have a queue, this is the consumer. Okay, this is the producer. Always a good practice to create the consumer to come and wait on the queue. There, then you start producing it. Okay, it's like better thing to do than doing the other way, because message queue will be full by the time you maybe start creating it. Okay, so that's why everything has to be very thought of. What is the order? So I'm incrementing it. Maybe even this also should have been done here, because that's the reason I missed the prime number. I think one is a prime number, I suppose. I don't know. I think so. Okay. But I'm missing it because it is incrementing it, or any reason. I'm not missing anything, but just maybe we could have done this threads first, and then increment thread could have been done last. Okay. That I leave it to you. Okay. Whichever makes sense, you do it. Okay. Now numq put. How do you put the value into it? Some count value, whichever satisfies the condition, you are going to put into the queue. This will be called by all the threads which are sending the message to the queue. Similarly, the display thread is going to read from it by using a get method, and it is going to write into its own local copy, and then it is going to print it. That's all. So very simple interface. You don't need to worry too much. It can be done easily with the code that I have shared with the last session. So output will be like this. Exactly same output you should get. Okay, both should not look different at all, except that display thread is saying that I am creating started. After that, these prints will be exactly same. Only thing is, now they are coming from the display task rather than from the individual threads. That's all is the difference. Otherwise, the sequence will be the same because the number is getting incremented in the same order and they will be printed like this. Okay. So, but only the other difference is everybody is saying that I am display thread is only printing. Okay. It is not the individual thread. As I told you, you don't need to worry about which thread is calling, sending the message. So you can print it. That's all I have.